Um, Again, this is I'm going to share the entire desktop. Um, this is lecture 17, and the reason I share this annotated slide of lecture 16 is that just to remind you that the quiz 4 is next week, next class. That's on Thursday. And again, I'll release that. It's a 24-hour window, so you can answer anytime after I release. And it's going to be on slides that I already mentioned on Campusware. The topics are everything after the nano remediation or nanotechnology. So that was part of the last quiz. So that means it will be on the landfill. So there will be more question on landfill, how different design, different layers has what functions. That's one thing you should check. And then you should check other aspect of other new stuff that we learn. Okay, so it's a very simple questions because there are not much mathematics involved here or concept questions. So it should be fine. But this is one last thing, you got to do. And then project draft, I know that some group already sent me but the reason I set a deadline March 9, which is next Monday, which is 1 week more than what is on the syllabus, is because and again that's normal. People need more times. There's always so just send me whenever you are done within this until March 9. The reason I put March 9 is because I want to get it back to you by the last class. That way and you can discuss that day with me, any any of those comments directly. And so then you can submit on same week or the week 10 anytime, or you can submit on the final week. It's up to you, because once you see the comments, that you have almost more than a week to submit. But I encourage you to submit immediately. You don't need to waste a lot of time, because whatever comments you have, just address it and submit. Okay. 10-minute video, you got to do it. So that has to be done before the class, because I'm going to share at least some of the videos, at least the link in that slide. That way it stays forever. So send me the YouTube link of your group presentations. That way we could, I send those links before to all of you so that everybody can watch each other teams. Normally people present in the class. Here we don't have to do that, because just we can discuss rather about your project, and everybody can watch on YouTube. I'll put the link on the in one folder so that everybody can see those. So that's the announcement. And second thing I wanted to do today is to the first step we'll discuss about projects. Something. Imagine this is a project that is assigned to you, how you would have done. And this is the projects I have worked on before. So that's why I thought I'll share with you. This was based on my experience as a postdoc. So let me put that. Um, so this is center I worked before I joined here. It was the bioremediation of asbestos. So I'll tell you a little bit story about that, and also a little bit other aspect of it now. So this is a presentation I gave it um, it's a very public setting. So it's a community which was affected by asbestos. So this is something you got to think of. This is obviously everybody has their own preference how you should present. But when you present, always think that you are presenting to people, not scientists all the time. Even scientists are people. So you got to connect. You got to tell the story. It also goes to your draft or your project report. Do not make it very passive. Do not make it also too. I mean, science has to be there, but it has to connect with people. Now, that's the point I want to say. So this was the asbestos projects. I just want to show you. This is a picture of me in India at one locations. And the highlight of this picture is the look at how people live, and the location where I'm from. At least some people. It's not my home. They are close knit people. They know each other by name. They know everything. I mean, they are just like middle of night. If you ask anything, they will be there for you. This kind of community is a different feelings there. and they dry their home, their dress, everything on the roof, because that's where they can dry. But notice the roof. What is this roof made up of? Anybody can guess?
Like some kind of reed or straw or something.
Yeah, it's a straw. So it's a rice straw. Okay, so rice is one of the biggest, you plant the food that everybody grow in India. So that's the rice straw. They put it there. So majority of the people have rice straw as their roof, which is good because kind of air conditioning. In the winter it will be warm, in summer it will be cool. Uh, but at the same time, it is also fire hazard. So that's the reason a lot of times there is fire and a lot of people get their house destroyed. So this is one of the incentive. That's why there are many places government give them asbestos roof. Okay, and the reason I want to start with this is asbestos is toxic, but asbestos also is could be a their life saving if their house is burned. So you got to put a context to where it is important, because there are many places in developing country they use asbestos as a roof. Things are changing, but just as a context. Okay. And then if you think of what the asbestos are, this is asbestos look like in US or here. You might find in a big building or an old building. If you go, then you have insulation materials. Those insulators are made up of asbestos. Asbestos are a natural occurring mineral like sand. It's a silica. Same thing, it has silica, magnesium. I'll show you a picture of it. But the point is, it's a natural containing minerals. So there's no difference between a fibrous sand. I mean, there's nothing called fibrous sand, but fiber silica versus asbestos. It's in terms of it's a natural material, and it has unique property. It's extremely rigid in the sense it's not going to be abraded very easily. So that means you can use it without worrying about things being destroyed over time or eroded away. And also it has excellent thermal insulation capacity. It doesn't conduct heat. So that's the reason asbestos has been used in many forms. When asbestos was found initially, it was called miracle minerals, because people suddenly find a way to use raw rock for everything. That time they call mineral the miracle rock. It can create a thread out of it. You can create a you can put asbestos on a to filter wine or beer. People do that. That time, and they do all these kind of they put asbestos anywhere they don't want things to be abraded. For instance, tire or any products. People use asbestos for like in oven. Every time you want to take off your baked cake, you want to hold something that is made of asbestos. So there are many materials was used in finite products. And but then they found out 1960s, around then they find out everybody who works in asbestos industry, they start developing lung cancer. That time they were not sure why they are developing, but there was a correlation. So then once people find out, for instance, here, if you see, this is Ambler, Pennsylvania. That's where we worked, or I worked there. This was a site in 1950s, or what I have to check was the time. But you can see this was the asbestos containing material. So all the asbestos, everything dump into this pile. People take picture there because that was a sight to behold, and that time nobody knew this is toxic. So just to give a context, what we are using now, think this is the best. In future, we might find something this is bad. Okay, uh, so this is just to show that we learn from the process. But the point I want to say is, once we nail these asbestos, they are so they are rigid. Like you see this picture over here, they are asbestos. It's stuck in the lung, and once it's stuck in the lung, like silica, it's not destroyed, and your lung create chemicals to destroy any foreign materials. And the same thing it happens when you have asbestos. The difference is asbestos is extremely difficult to degrade. So that's why you see this. The people develop lung cancer. So the white color, all that stops is cancerous cell. So this is again, as you saw here, there's asbestos particles, this big fiber. the red arrow mark, that's the asbestos fiber. And then the macrophage, which is basically the defense mechanism of lung, the macrophage come in and they engulf it. And that's what they do when there is a pathogen. For instance, think of coronavirus or bacteria. Every time we inhale, they get into lungs. Our lung macrophage, they comes in and they engulf it. And then they try to destroy it. That's how you can see this, the blue color. Those are the macrophage. They engulf any particulate. That's how they destroy it. And the way they destroy is by creating radicals, oxidized hydroxyl radical. But now when they engulf these asbestos, they think they catch their the pathogens, so they start creating this hydroxyl radical, and then they realize that it's not being destroying. So they think, this is a really tough bug, so they want to create more and more until they realize that this hydroxyl radical itself is destroying the lung cell. Okay, so that's how just the simplest way to say that this is how oxidative stress occurs, and our lung become develop super immunity like a cancer cell. Cancer cell is something that cannot be destroyed. That's how the whole cancer. It's a cell that goes crazy, they can be die. Okay, so they multiply much quicker. So this is the cause of cancer cells, just to show that if your asbestos has iron, it produces more toxicity. So now that I give you this background, um, this is where we have to pause and start discussing what we could do if you find out that that the places where the soil, imagine there is a soil in a small portion of soil like Ambler I show you, has a lot of asbestos, and you found that iron is the cause of increased toxicity. So your goal as a consultant is to create a plan to remediate the site. Okay, so every information that you know so far, what's the approach you will take? So I'm going to stop the share so that we can start discussing about it. Then we can go to the slide. So three things we learn. Asbestos is natural. It's magnesium. Think of magnesium. It's like a clay or the silicon oxide, but it has also magnesium hydroxide on the side. It has some iron. So basically, it's a natural material. Silicon, magnesium, oxygen, irons. These are present in asbestos. So those are at itself is benign, right? But when they are the crystalline form, those fibers cause the toxicity. Mostly the iron is correlated to toxicity. And asbestos is toxic because it's more toxic when you inhale as opposed to other way. Okay, so these are the 5 different things you will learn. So now you as a group have to come up with a plan to minimize exposure, because that's the first remediation strategy, is minimize exposure. And then once you minimize it, somehow find a way to destroy it. Okay, so these are the 2 approaches we are going to have. So now let's start with thinking, what kind of remediation plan you will have. Number 1, let's say what we can do to minimize asbestos exposure. And if it's exposure, which route you want to minimize and how. Any volunteers? This is again, we'll discuss like as if this is a real project for this class. So I gave you already the introductions. I say what is asbestos, what's the problem, what's the site, what cause, all that. Now it's all about the materials method or the method section of your project. Imagining this is asbestos remediation project. So what's the first step we can do to prevent the people over there who lives around those sites to not expose to asbestos?
Maybe figure out like the exposure pathway, like if like what is causing it to, escape so that it's in the air so that they can breathe it in.
Okay, yeah, that's a good point. So first is to assessment, exposure assessment or pathways. So let's start with that one. We have how many different pathways you can get exposed to pollutants?
Like ingestion, like respiratory,
Okay,
tactile, I guess. I don't know, having
yeah.
having it touch your skin.
Okay, so it can touch your skin. You can inhale them. That's the second exposure. Ingestion, you can if it's polluted with water, you can drink it. What else? We got skin, inhalations, drinking. Is there any other way? So we take care of water, which is injection. We took care of inhalation, which is air. We also took care of the direct touch, which is soil, right? So that's the three ways. So we have three sites, so three mediums. So that's the three ways. That's good. So now let's look for one at a time. How much toxicity is? Let's rule out which one you don't want to focus on. So among those three, which one you don't want to focus on? Or it's not a big risk based on what you know so far.
Touching it.
Which one?
Oh, touch.
Yeah, touching. So because in nowhere you see that it is a skin toxicity. It's not a chemical that react with the skin. Okay, so if you hold asbestos, it's not going to be toxic. Okay, so that's the reason people were using asbestos, right? So there's nothing wrong with holding them. So you don't have to worry about that aspect. So now you have two choices: um, minimizing the exposure through water and minimizing exposure through air. Which one you will put more resource on, based on what you know?
Minimizing. Oh,
Go ahead.
sorry. You could. Oh, I was saying minimizing exposure through air because that's how majority of people contract with asbestos.
Yeah. So what evidence I say that will be air related? So we always have to connect with, right? So what evidence I saw that made you to decide the air is the path?
It's like the fact that it's really light and it's like easily dislodged, which causes it to like when you inhale it, it causes
Okay.
lung problems.
Yes, basically long disease, So long disease is the reason. So if you have to write this portion, you will talk about that, The majority of people who are affected by asbestos will develop lung cancers. So that means it has to be air transport route, right? So the reason I say this one is because think of initially when we handle coronavirus, 90% time our research was more about washing our hand, all that stuff, which was okay, but really, the majority of the infection happen because of inhalation. So if you're not using mask, if you're not taking care of the ventilations, it really doesn't matter how much careful you are in terms of cleaning your hands. Or I mean, it's helpful, but it's not as important. I mean, it's not in the same level, right? So a lot of times when you think of remediation, this is how you will make those arguments. So, okay, so we took care of. So we'll go to the air route. Then let's think of a moment. What about water? Do you think even anywhere I said, do you think even asbestos can move in water? If so, which water? Is this surface water? Is this groundwater? Or is it drinking water? Think of that. Based on what you learn in this class, that way we can have a logically decide where to focus on. So think of asbestos pile. So I'm going to share the that's let's say this is the one you always focus on. So imagine this pile is over here. Okay, there are we decided that okay, air medium is one of the reasons. So that means we have to prevent any kind of any kind of entrainments into air. So you don't want to inhale anything. So what are the three different water source from where you can get asbestos you can find in this site? So one is surface water, another is groundwater, another is drinking water. Most of the time, drinking water can be also groundwater if you have injection well. So which water will have more asbestos?
I'm thinking surface water, mostly because if these fibers are relatively light and I guess fragile in a way, they would most likely be transported through surface waters. It would, I think, take much longer and it might just get absorbed into soil before getting down into groundwater.
Exactly. So if you remember when nanoparticle transport or something, you realize that if you have large particles, it can be strained out. The pore size, if it's size bigger than that, most of things can be removed, right? So adsorption or the filtrations can be efficiently remove asbestos. So that means your risk is low if you are looking at asbestos underground, like in groundwater. We'll discuss that later, but point is, now you realize that you have two biggest route of exposures. One is air, another is water. Okay. The reason I say why water is also important is because imagine every time it rain here, what will happen? Any small fiber on the surface is going to wash up from there, and they'll travel as far as the runoff goes, and they'll deposit all this asbestos there, and then it will dry out, right? So it doesn't rain all the time, so it dry out, and when it dry out, it becomes again dust, and next time there is a wind, it will blow on again all those asbestos. So that means you got to think of how to minimize erosion from this side so that you have a minimum exposure. So now we come to the point where we decided that these two systems we have to change, minimize. So now you tell me, based on what you understood in this project, in not in the project, in the class, what's the different way to prevent any kind of dust to emit from surface? And second, what's the different way to trap any kind of dust or particulates coming, leaving the living area?
Usually, don't you spray water on it?
So spray water. So that's a good point. So that means anytime you want to do anything over here, spray water so that there is less dust, right? It is going to be practical. You know, how long you going to do it, right? I mean, things you can't continue doing it because all the time there will be. So that's probably, you know, one way good if you are doing directly something, just spray water and work on this area so that you're not inhaling. So which is what we did actually. Anytime we went there to collect samples for our studies, we spray water and then we dig soil from there. Okay, so that's the one sampling assessment or sampling plan. That's something Hannah already determined what the protocol should be. So now next thing is how to permanently not have any asbestos in air or entering into air. What should you do? Let me open the chat window, because if you are somebody's, yeah, somebody says, could you bury in a landfill? That's a good point, Matthew. So that's a good point actually. So let's say we are going to bury in landfill. So to what do we do if we have to bury this one in the landfill? What's the process of first step? To take this one from, because this is not a landfill, right? This is the place somebody's, you know, near home, right? So to send it to landfill, the first thing you have to do is you dig the soil, right? You have to put them in the truck and then you haul them out to landfill. So imagine what will happen when you do that.
There'd probably be some like I guess dispersion as it's being transported to the truck, I guess, like as it's moving.
Yes, so anytime you dig soil, you create dust, you create particles, you disperse them. So the people who are digging, they are now exposed to asbestos. So they are getting very high dose of asbestos. And obviously they can put mask, all that, but still, you know, it can leave the system. And now you are actually exposing that asbestos to wider community around it. So you cannot dig it. So that's one of the reason this location you cannot dig. No matter what, you cannot dig the soil because you are now increasing the risk for everybody around it. So if you can dig, what you should do?
Could it be like chemically oxidized and broken down in some way?
Yes, that we'll learn about that. So let's say that's imagine there will be a lot of chemicals. So that means, you know, imagine if I give you a rock and ask you that dissolve it, think of what you have to do, right? So this is a rock, and this is not a just rock. This is a resistant rock. These rocks are very tough. That's why it is being used. It's a chemical resistant. That's why asbestos is used for many products so that it can be used as a protective layer. Okay, Ahmad says we can put a cap on it. And that's exactly the remediation technology. You put a cap, okay? So the remediation of this project or this site is basically getting soil from elsewhere and put 2 feet or 3 feet or even 6 feet layer of soil above it, okay? The reason you don't want to put a small layer of soil is because over time things will erode. and then at some point it will expose to it. Okay, so some places you have to put 6 feet of soil, and that's going to be expensive too. So put a cap is going to be expensive. 6 feet of soil, where you get it, right? So that's another thing you have to think of. And there is another option. One other option is you put a smaller cap, but make sure that cap doesn't erode with time. Okay, and so how do you do that? So what makes the soil erode, or what prevents the soil to be eroded?
Well, having like healthy root systems. Oh, sorry, go ahead.
I was
Yes.
gonna say the compaction.
So compaction is one thing. You'll compact, but over time, no matter what, there will be some erosion, right? So the way things don't get eroded, if you have lots of grass on it, like you have roots, you have plants. So unless you put a plant on it, it's not going to be sustainable in long term. So that means you put a cap, and then you have to put plant on it, right? Okay, so we learned that one. So now next challenge is this: when you put a plant, asbestos, these are like there's nothing there. It's a rock that doesn't have any nutrients, so plant cannot grow on it because it's just a infertile land. So what you could do, if you have to grow on it, what kind of materials you have to add? Let's say you have a soil gardens, you move to a place, Los Angeles, and nothing grows there, and you want to create a garden. What do you do?
Fertilizer.
Fertilizer. What kind of fertilizer?
Phosphorus and nitrogen.
Yes, but just phosphorus nitrogen is not enough, right? Because that's, if you see, remember what microbe need, what we added. If you remember that ratio, phosphorus is 10 times less than nitrogen,
Then
carbon. So you got to put a lot of carbon. So where do you get those carbon? Yeah,
Something
that's
like biochar.
biochar. Yes, that has carbon, but those carbons are very difficult to degrade, right? Because that's why they are sequestered. So you got to get something else. What's the cheapest source of carbon anywhere?
Just compost.
Yes, so get the compost or get the biosolid from wastewater treatment plants, or you could get um, the leaves, the decomposed leaves. So that's how you can mulch all that. So that means the remediation strategy at this location would be: first you decided that every other possibility, the chemical is expensive because it's just dissolving rock will take a lot of chemicals and you will destroy the land itself. And then you realize, okay, covering is, you can't put it in the landfill, so that's going to work. um, so William talk about fungi. I think he revealed my secret, because that's the fungi is the last thing I want you to get to that. But let's learn step by step. Okay. So we learned that we have to put kind of cap so that it doesn't really expose the asbestos or prevent inhalation. And then we realized, if you put a cap, you want the cap to stay for longer. And it's also expensive to put too much cap because you got to get soil from elsewhere. So you realize that, okay, to make the cap stable, you got to put some kind of plant. But those plants will not grow in asbestos soil or the soil. So you got to put some kind of nutrients or fertilizer. And then you realize, okay, I can add some carbon source like compost or biosolid in the mix. So now you create a capping layer with selective composition. Okay, and you put plants on it. And in fact, that's the remediation design of this site. If you think of what, so you see, as you see, we gone through different stages and realize what to do. And every time you rule out one effective methods and least effective method, and to come up with the solutions. Okay. So now the point is we did all that. And then what will happen? We put the cap, we put the compost, everything else. There is no air inhalation. So that means you never have to worry about, as long as that cap is there. So now everything is buried underground, right? And now question is how long? Because there can be earthquake. There could be, let's say, big tree that uprooted and then things will again expose. So so what we could do to make sure that these rocks will also become non-toxic. Okay. So then the point here is this: you realize it's not the asbestos which is toxic, at least in terms of toxicity. Here it says iron enhances asbestos toxicity, right? So then you realize the cause, if iron is the cause, then why not we just do things so that it doesn't have any more iron, right? So that's the now question is, how do you dissolve iron? So that's something you can now learn back from the basic thing that we learned in CEE163, how do you dissolve any metal? So think of how do you dissolve metal?
You have to change the pH.
pH. If you want to know how you dissolve metals, think of all the rust you develop in your car engine or anywhere, and you put, what do you put there if you want to clear it up or clean it up? Let's say you have a rusted iron and I want you to clean it up. So what should you add there? Anything usable products, things that you can buy.
But like basic products like baking powder.
That's one option. So that's going to increase the pH. So what other thing you could do? You
Put
say,
something very acidic on it.
yeah, so you need acidic water. So where you can buy acidic water? If I ask you 1 liter of acidic water, where do you get it?
Vinegar,
This is one.
something stronger.
No, that's good. Vinegar is acetic acid. So what else you can buy? Vinegar you have to buy. You have to go to uh, you have to go to a specific store. What you can buy everywhere where the pH will be less than 4. In almost every place you can buy. What? Somebody say, how much a lemon? You got to buy a lot of lemon. So it's very expensive. That will not be feasible. What else? You can buy carbonic acid. And do you know where to get carbonic acid? Lots of carbonic acid. pH is low. You know what? You drink every day that.
Coca-Cola?
Soda?
Exactly. So get all the cokes you can and pour on it, and you'll see the magic happen. So the coke or anything, any soda drinks has a pH around 3.6 or 7 because they dissolve a lot of carbon. So to make it like, when you open it up, that you see that air comes out, and so that's the carbonic acid. So the pH of coke is 3.7. Okay. So if you pour your coke on a car engine, it will look like new. So this is just another thing you learn. So that means, anyway, point is you got to make the acid. So now, so imagine this side, you say that let's buy lots of coke and just pour it here. It's going to be too expensive, right? You don't want to have pouring cokes all the time there. So what you could do? Okay, so that's here. This is just to show. This is the capping, 6 feet of capping that going on. So they are putting this soil layer, and this is unexposed or exposed without capping. So they are slowly capping that time when I take the pictures. And this is what they'll look like at the end. Okay, so you put the grass, you put this mulch, organic, so that grass can grow, and then it becomes stable. So as you see, before even I tell you the answer, you guys come up with an answer. So now the last point of this one is how to remove iron. So you can pour a lot of coke, obviously, if you want to lower the pH, but that's not going to be cheap. Who's going to pour all the coke or vinegar on soil? So you want to create the or the acid in the soil all the time. So due to that, you have to think of how you can create biologically acid or vinegar. Okay, vinegar is acetic acid. So that's what it comes to fungi. Okay, so the way the fungi are evolved to do that more efficiently, because they do not have a direct source of carbon, because everybody need carbon nutrients, and fungi, they cannot get carbon, so they rely on most of the time plants to give them carbon. And plants are the source of carbon in the world, because they take carbon dioxide, photosynthesize it, and make everything carbon, right? So they can give carbon at any times. So these exudates, or they release these organic acid to dissolve any nutrients around the soil, so that plants can have those nutrients, and in return plants give them back organic carbon, or this breakdown carbon, so that they can coexist. So these colonizing fungi are very efficient at getting nutrients, and it happens to be one of the nutrients they get is iron, because iron is a micronutrient and it's very difficult to dissolve. So these fungi always use this method to develop the process. So now that you know that this is a part of phytoremediations, you just all you have to do is find a plant which can accumulate lots of iron. Number one design, okay, that way you can collect all the iron, remove it. Number two, find a plant which has a lot of fungi on the root. So root mycorrhizal fungi, okay, that means they grow near the roots. So once you find those fungi or the plants, you grow them there. And then obviously once they grow over time, they release this excudent, and you are hoping that any small fiber exposed to this excudent will release that, takes the iron out of those systems. And over time, because it's all capped anyway on the underground, those asbestos becoming less and less and less toxic. So that was the project of that field, and just to show that regular plant root, and if you have fungi, they create these filaments, they can spread around, so they can reach out to all the different asbestos everywhere. So that was the concept of the fungi projects. This is just to show that these filaments can get into the rock and create this channel, and those channel, that's where they release those things and create these fractures and dissolve. And fungi are everywhere. If you see, this is something you eat fungi. If you think of getting the different kind of penicillin is a fungi. Okay, that's although it comes from fungi. If you eat bread, that's because of fungi. Starch, all that. So you create beer, that because of fungi, or yeast, and then you have all this cheese and everything else, or soy sauce. So basically, you do that same thing. You create this system, and you put these fungal exudates or the chemicals they release, and then we show that it can remove, decrease the iron. So this is just a picture to show that it's very hard to see here, that how much iron can come out if you are exposed to those exudate that comes out of those fungi or plant. So as you see, if you put zero millimole, means no exudates in that system, the iron concentration, which is black color, black square, is zero, almost zero. That means nothing is coming out. If you expose to a very small quantity of 1 micromole of DFO, that's a chemical that is released by fungi, it release iron, more iron. So that's the work we did. And so the take home message here is that you just have to, you have a asbestos, you put a cap to prevent erosions, and then you put plants so that the eroded material remains stable. And then hopefully the fungi is going to release the iron, so that even though there will be asbestos, it will be less toxic than what it was before. Again, just to show that this is again the professor where I was working with that time, and these are my colleague. He's an undergrad student, Oskan, pre-med student at that time, and he's now a doctor, or he's becoming a doctor in Chicago, and so all that. All right, so that's just basically just to show you that if asbestos, I would have given you this site and say that, look, this is asbestos site. This is the logical process you would have explained, and develop your projects and discuss all that and eliminate different process and say that this is how I'm going to do it. So this is consulting job. Basically, every time you get a project, you will think like this, ruling out different options. So you learn that in this class without even realizing. If you have more practice, you will learn a lot more to do it. So every class, I'll pick a problem and discuss like this, so that you see that how you yourself will come up with the solutions without me telling you the solutions. All right, so let's take a break for this is 4:46. Let's take a long break. Long break, and the reason is I want to feed my son for 10 minutes. So let's meet at 5 o'clock. Okay. I'll be back at 5 o'clock, and then we'll discuss your projects and also share some example project. All right, so there are some question. Is this a fungi able to break down the iron, or if it is not, what does end up? No, fungi doesn't break down iron. What they do is they create this chemical that will, it's like hemoglobin. Hemoglobin hold the irons very effectively. So it has iron, that's how it hold the oxygen. The same thing, these exudates will bleach iron out of the asbestos. So what will remaining is asbestos without iron, and that will be less toxic. And then obviously once iron is outside, it can be used by, taken up by plants, it can be taken up by bacteria, because that's what they're after, looking after this. Okay, all right, so we'll meet at 5 o'clock.